Welcome to Envelope. I am Eldad Gothelf, and with me today are Brian Lott and Rachel Bristow and Ben Norman, just a portion of our team. I'm going to summarize very briefly what we do. Brian's going to talk about some of the data we pull in and the GIS challenges we face. Rachel's going to talk about translating zoning into code, and she's going to give a demo of the software, which is so cool. And Ben is going to talk about the challenges of ownership data. So what we do, at its core, our tech identifies, interprets, and visualizes zoning regulations and how they impact the development potential of any site in New York City. Understanding the data accurately in 2D, coupled with our ability to visualize in 3D, puts us in a unique and advantageous position. So zoning at its core regulates two things, use and bulk. What can I do and how much can I do of it? This spatial question is a real challenge in such a complex regulatory environment such as ours. And so how much can I build is not an easy question to answer, right? Every site in New York City has an FAR, a floor area ratio, which is a number that when multiplied by the lot area gives you your total development potential. This underscores the need to get the 2D data right, because when you're wrong in 2D, you're that much more wrong in 3D. So we do analysis of what can be built on a lot, but whatever we do on one lot, we can do on multiple lots in order to accommodate for assemblages. We also account for bonuses such as inclusionary housing or fresh grocery store bonuses. And the coolest piece of it for me is the ability to understand what development rights are available next door and whether or not they can fit within your zoning envelope. So our proprietary technology, which has essentially given us a survey grade parcel map of the entire city, coupled with our street width database and precise understanding of the location of zoning boundaries, puts us in a position to have the most accurate understanding of a site's development potential, which translates into real value when you're thinking about buying, selling, developing, or rezoning a site. I'm going to turn it over to Brian now to get into the gory details.
Thanks, Eldad. Let me start presenting. Hopefully everyone can see my presentation screen.
Yep.
All right. So let's get started. So my name is Brian Lott, and I am the spatial database engineer at Envelope. That makes me about 60% software engineer and about 40% GIS technician. And I do a lot of work on open data and transform it into things that we can use in our product. And so today I'm going to, we're all really going to, show you how we do this on a lot. And we have selected a lot for a case study today. Just so you know, all the speakers you hear today are going to talk about this lot and sort of the different ways that we can analyze it using open data. So we selected a lot in Manhattan. It's 233 Park Avenue South. It's at the corner of Park Avenue South and 19th Street, or as we lovingly call it, Manhattan Block 874, Lot 4. You can see that this is a nice corner lot. It's got a nice building on it. Building has looks like it might have a rooftop cafe or something. That's nice. So this might be a piece of real estate that we're interested in. We like to analyze it. So I'll show you guys how we use open data to analyze this lot. And where does it start? Well, it starts in the beginning. I should say, get a little ahead of myself here, but to begin with, there's the question of how we use open data in our analysis. And we really use it in two ways. One way is we take the data sets and we improve them to make them more accurate spatially. And then once we have an improved data set, we can actually derive new data sets from it that really weren't available before. So this is how we sort of build up the data sets that go into our analysis. So now, like I said, I got a little ahead of myself, but where do we start? We start at the beginning, and that's really with two open data sets. The first one being the Pluto data set that comes from the Department of City Planning, and then the digital tax map data set that comes from the Department of Finance. We like the Pluto data set. It has a lot of attributes that are relevant to our industry. But then we also we like the digital tax map because it actually has some survey measurements of the dimensions of the lots. And this is pretty important to us. What you'll find is the lot we're looking at today is lot 4 is roughly 150 feet by 82 feet per the digital tax map. But when we start looking at it in GIS, we'll see that the actual dimensions are a little overstated in Pluto. So when we actually measure this thing, it's supposed to be 150 by 82. It really sort of measures out about 155 by 85. I did a rough back of the envelope estimate on that, and so that's sort of overstating the square footage of the area by about 500 square feet. So this is sort of the problem that Eldad alluded to earlier. If our square footage is too large to begin with, and then we start adding 10 floors, well, if we had 10 floors, now we're off by 5,000 square feet. So getting the lot dimensions accurate is important. So first step toward our lot analysis will be actually adjusting the boundaries of the data set to make the lot dimensions more accurate. This was a major investment for us. It took a great deal of custom software development plus some manual intervention to sort of bring this data set together. But doing so brings real value in having a very accurate set of boundaries on the ground. It really helps us understand the ground better. So this is sort of where we start. The very next step, once we have adjusted lots, has to do with zoning districts. Again, our zoning district data begins its life as an open data source. It comes from the Department of City Planning. They have a GIS zoning districts layer that they provide, and that's what we see here is the city's version. The city's version does not align with Pluto, and they state that they don't effectively. But even if they did, their alignments would not be correct anymore because we have adjusted the underlying lot geometries. So in this case, this red boundary that separates a commercial zoning district, the C6-4A, from this residential district, should be at 100 feet from the edge of the street. But when we actually measure it, we find that it's at 92 feet. That's partially because it was a little off to begin with, and then it got a lot off when we adjusted the lot boundaries underneath it. So for this to be right, we're going to have to adjust it as well. So the way we adjust these sorts of boundaries is we'll actually create a target line that informs us where we want that zoning district across the block. And then we'll make some adjustments to actually pull that line over. So as you can see, these are our adjusted boundaries, and we've made them more accurate relative to the more accurate lot boundaries that we already have. So this is sort of another example of how we would improve an open data set. Beyond that, this is sort of ways that we improve open data sets, but then we can also derive some additional data from these improved boundaries. I'll have a couple examples of that. The first is corner areas. So in New York City zoning, there are special considerations for areas that are within 100 feet of a street corner. So what we did to find these areas is we actually took our adjusted lot boundaries and then created 100 foot by 100 foot squares from the corners to indicate where those areas are. Now this block is actually short along its avenue. So in this case, the two corner areas kind of overlapped one another and just became one big rectangle that basically indicates that the entire end of the block is in a corner area. But this is a good example of a piece of data we can derive because we have accurate boundaries. Try to take this, pull this from inaccurate boundaries, and you're going to wind up with inaccurate results. A slightly more complex example of this would be street widths. Street widths is another key thing that in terms of accuracy. Street widths come into play in a couple of ways in New York City zoning. One is that the actual street width itself, in some cases, may limit the height of the building that you can build. So that's when you really want to know the exact width of the street. Then more generally and sort of more commonly, there are special rules that apply to lots that are on wide streets. When a street is wider than 75 feet wide, it's considered to be a wide street. And if you are adjacent to that, then some rules apply. So what we found, and the key insight about the fact that we adjusted the lot boundaries, the lot dimensions to make them more accurate, is that also makes the street widths, the areas in between the lots, more accurate. So by improving the lot boundaries and the lot geometries, we improve the accuracy of the street areas. So what we do is we have an algorithm that goes and actually takes several measurements between the edges of the blocks and sort of averages them to come up with an average street width. In this case, we measured these streets at about 99 feet and about 60 feet. And at this point, we can check in on yet another open data data set. There is a data set called City Streets. It's provided by the Department of City Planning, and it also has some attributes that describe the width of the streets. And so, as a cross check for us to make sure that we are, doing things correctly, we will compare our measurements to the city's measurements. And in this case, the city says that this is a 60-foot street, and that's about how we measure it. They say this is a 100-foot street, and we're pretty close to that too. So we like these measurements. We feel like they're pretty good. Now that we've taken these measurements, we know that on the avenue side of this lot is a wide street. So we're going to have some wide street rules apply. Those rules apply within 100 feet of the wide street. So what we do is we will take a lot edge and create a buffer off of it at 100 feet to describe where these rules apply. You can see we basically came up with the same area as corner lots earlier, though we did derive this in a different way. It's different logic, but came to the same conclusion here that the end of this block is in a wide street area. So how does all this come together? So we've defined some new data sets that help us define some areas, and we've also adjusted some existing data sets. And when we put all these pieces together, what we come up with is our primary lot that we feed into our massing engine and our zoning engine to create 3D renderings. As you can see, it's divided into two pieces. We call these pieces sublots, and each sublot indicates where different zoning rules apply. So after the analysis we did, we found that this area in the corner is substantially different than this rear area. The front area, the corner area is in a corner lot area. It is in a wide street area, and it's in a commercial zoning district, whereas the rear area is none of those things. It's a very different zoning situation in this portion of the lot and has to be handled differently. So at this point, that's sort of how, from the 2D perspective, we use open data to create sublots and sort of the setup for rendering these 3D buildings that we render. I'm going to hand it off to Rachel Bristow, and she is going to sort of explain how we consume this data and make our 3D renderings. And I will stop sharing. I'll turn it over to you, Rachel.
Thanks, Brian. So I'm going to very briefly touch on the technical side of how we apply zoning rules before jumping into a demo of the product itself so you can see how it works. So as Eldad mentioned, we've translated the legal text of the zoning resolution into machine-readable code, which we call the zoning rules engine. And using a series of lookups, it's able to determine the set of parameters that apply to each lot or part of a lot. So as Brian mentioned, like different sublots have different sets of rules that apply to them. So I'm showing a kind of simplified table here that will help us understand how the maximum floor area ratio, or FAR, would be determined for a lot in an R6 district. So there's a few different aspects that determine which value applies, which are represented by the 4 columns on the left. So we know it's an R6 zoning district. We then need to ask what bulk type are we using, like which set of bulk rules, whether we're using quality housing or height factor, which are the sort of 2 sets of rules that are allowed here. If you're using using quality housing, it then matters whether the site is within 100 feet of a wide street. And we have that information because of the analysis that Brian mentioned. And if it is within 100 feet of a wide street, we need to know whether the site's in the Manhattan core, which is community districts 1 through 8. So the app kind of very quickly runs through all of these options and matches on the most specific value that applies to your particular site. And that gives you your maximum FAR value and a citation, which links back to the zoning text. And so this is just one parameter that we look at for one district. So we have similar tables for similar lookups for every high density district in the city, for floor area ratio, for maximum height, maximum base height, setbacks, lot coverage, yards, all those things, as well as different kind of layers of information. So if you're in a special district where a bonus applies, it needs to be able to look up those rules. If you're in a special district like, I don't know, Midtown or Hudson Yards, say, it needs to know that those special district rules override the underlying zoning, and it's able to do that. And so the point being that as a human, figuring out all these rules that apply can take like many, many hours of cross-checking the zoning resolution, whereas making it machine readable, it can be done in an instant. So now I'm going to flip over into a demo of the product. Can you see this, guys? Good, cool.
Yes.
All right, thank you. So I'm showing the same lot that Brian was talking about earlier. I'm going to flip on a layer that shows primary districts so we can see that district boundary that he mentioned that splits it between a commercial district and a residential district. And you can see across the street, this is a manufacturing district over here. Just a way of seeing those different districts in a color-coded way. When we click into the lot, we get some information about the zoning districts that apply. We can see that it's split between those 2, as we mentioned. We have some information about lot area, also development rights, and the existing built area that's on the lot. So here, because it is a split lot, the app is able to calculate the potential ZFA based on that split. So it knows that C64A has 10 FAR, R8B has 4, and so it averages out to get 8 here. We also have this attributes tab, which has a bit more information about the existing building, which pretty much all just comes straight from Pluto. And then let's turn on the 3D context. All right, and then we can spin around so we can see a lot. I'll zoom in here as well. So we use, the city has a pretty great 3D buildings model that we use for this context model. Gives us a good idea of what's existing on the site and in the surrounding blocks. And we can also turn off blocks around so we can focus in on our site. And then if I hit run scenario here, I think I have to swing it around again. But you can straight away see that different rules are being applied to different parts of the lot based on the different rules that apply. So you can see there's a commercial ground floor on the corner, whereas it's fully residential on this part of the lot, different height limits that are being applied. And we can also here run through some different use options. So if we wanted to do fully residential, fully commercial, you can see that in that case, part of the lot is empty because commercial use isn't allowed in this district. If you wanted to do a community facility like a school or a hospital, and then we can also do kind of combinations of uses. And you'll notice that the height and FAR values here adjust automatically as you do that. And then if we go into the rules tab, we can see the different rules that are being applied to each portion of the lot. So we've got the R8B interior, the C648 corner within 100 feet of a wide street. They have different maximum heights, different setbacks that are being applied based on the street width. One thing to notice here is in the corner, it defaults to 100% lot coverage, which is technically allowed by zoning, but might not be the most efficient or reasonable floor plate. So we can override that value. So I'm going to make that 85. And you can see that that sort of made a little cutout here in the back so that you can have windows, and it also changed the height of the building. So yeah, it's pretty great to be able to override those things and see it automatically update rather than like having to start from scratch if you're doing this sort of as an architect. And then in the additional tab here, we have things like bonuses. So inclusionary housing bonus applies here, so we can add that, and it automatically adds that floor area and updates the maximum height. In this case, there's no air rights available on the adjacent lots, but if there were, you could add them here. And then, so we're maxed out for height, but we still have some, so maxed out for floor area, but we've still got some height available here to play with. So again, we can kind of override different values to make that work for what we want. So I'm going to make a nice tall ground floor and update the residential floor height, and then that maxes out the height as well as the floor area ratio. You can zoom out and turn on your surrounding buildings. You can see how that looks in context. Another thing I wanted to demo was something we've just added recently, which is this zoning district override, which allows us to kind of explore different rezoning scenarios. So we can sort of play with what if the R8B portion was rezoned to match the rest of the lot, and you'll see that the scenario kind of automatically updated to apply those rules across the whole site. And one last thing I wanted to show was that, yeah, as Eldad mentioned, everything we can do on a single lot, we can also do as an assemblage. So what's going on here? All right, slight glitch. I typed in the wrong one. I'm going to throw it to the next person and deal with this behind the scenes. So Ben, would you like to take over here?
Yeah, let me share my screen.
Sorry about that, everyone.
Cool. Can y'all see the slides and hear me okay?
Yep.
Yes.
Great. So in addition to understanding the zoning of a property, figuring out who actually owns it is really important. That actually turns out to be pretty difficult. You can't just take an address and search in Google and have it tell you who owns it. And even if you do find ownership information, oftentimes the real owner of the property is hidden behind some anonymous LLC. So a really common pattern you'll see in New York is you'll have just the property address and an LLC slapped onto the end of it, which doesn't tell us anything useful about who actually owns the property. So what would we like in a ownership data set? The first is that we'd love ownership information in a structured format. It would be nice to have data that reveals the true owner and not just some anonymous LLC. It could also be kind of nice to view all the properties that a single company owns. So before I dive into how we do that, I wanted to just highlight a public project by Just Fix It called Who Owns What, and they kind of handle ownership for residential properties. So I'd recommend checking that out. So where do we start for our ownership data set? We start at the New York City Department of Finance, Office of the City Register, Automated City Register Information System, also known as ACRIS. So what is ACRIS? ACRIS is a massive database, over 20 million scanned property legal documents for over 1 million properties in New York. And UF has taken the most important pieces of information from those documents and input them into a structured format. And I have 1 million questions about ACRIS, so if there's anyone from DOF here, I'd love to talk to you about it. So here's some screenshots from the lot that Brian and Rachel I've been looking at. And here are all of the documents associated with that property. So as you can see, there's deeds, mortgages, lease information. So let's take a look at one of these. So there's a mortgage here for so much money. So let's see what that's all about. So we can see up here, we have a lot of important information like the document amount, the document date, and the type of document. And if we go to the bottom here, we can see the parties associated with this document. And this is a mortgage. So the first party is the party that is paying the mortgage and the likely owners. So as you can see in address one field, there's a company name called Orta Management Corp, and they are located at 225 Park Avenue South. And so if they're paying the mortgage, they probably own the property. So there we have it. We have the owner. And we can confirm that by doing a little bit more research about this property. And I found an article that in fact confirms that Orta Management owns the property. So all these screenshots are from the ACRIS website, but if you want the 20 million documents in a structured format, they're available as data tables in the NYC Open Data portal. And there are 4 separate ACRIS tables, so make sure you get all 4 of them. Let's go back to our goals for this ownership data set. We wanted ownership information in a structured format, and that's available in the ACRIS data tables on Open Data. Great. We wanted data that reveals the true owner and not just an anonymous LLC. We're able to find that for the property. Small asterisks here, you won't be able to find the true owner for all properties in ACRIS, but you'll get pretty close. What about this third one? We wanted to view all properties that a company owns. We can't quite do that yet because companies use inconsistent address and company information name on their ACRIS documents. So here's a fake example of 5 ACRIS records from a single property, from a single company. So as you can see in the company name, there are like a couple of slight misspellings, and same in the address field. They're all pretty much the same, but a little bit different. And so it's pretty easy for a human to look at these 5 records and realize that these are all from the same company. But it's pretty difficult for a computer to do that, let alone on 20 million documents. So how are we going to resolve that? So we can first try and normalize all of these addresses using a geocoder, which just takes address information, parses it, and then tries to normalize it. And we use a open source geocoder called Paleos. We can feed our data through it, and we should get some perfectly normalized company address information. So after that step, we're able to easily group 2 of the 5 records here. There's still 3 records that we were not able to group because of these slight misspellings in the company name. So how are we going to resolve that? So this issue of trying to group similar but kind of messy records is called entity resolution. And there are a couple of packages out there that try and solve this problem. We use one called dedupe, which uses some machine learning algorithms to try and cluster similar records together. And if it's trained well enough, we should have perfectly normalized ACRIS documents. So I kind of zoomed through that whole process, but there's really 2 main takeaways I wanted to get at here. The first is that there are a bunch of good open source tools that can be used to clean and normalize sometimes messy open data. The second is that ACRIS has so much valuable information, and it is available as structured data on the Open Data portal. I'd love to see some more ACRIS projects because I think just the more eyes on the 20 million records in there, the better for everyone. So in summary, this is just a subset of the open data sets we use, and we want to thank all of the groups that maintain these. And we use all that data to create an accurate parcel map and derive zoning rules to create 3D models of zoning envelopes. And yeah, I'm going to pass it back to Eldad.
Thanks, Ben. While I get my screen situated, I see that there is 1 question in the chat. I would love to get a bunch of questions from you all. I see, like I said, a lot of familiar faces, and I know there's a lot of, well, you're all very smart, but a lot of people that I recognize as being involved in this world. And but if you could, if possible, there are these 3 geometric shapes at the top here. There's a Q&A functionality there. If you could try to use that, that would be, I think, easier for us to answer some questions. I'm going to share my screen again just to wrap this up. But if you could start asking questions there, and I will answer the 1 question that's already been posed. Okay, so you kind of take everything that you heard from Brian and Rachel and Ben, and you put it in a blender, and good people and good data and great software. And we use all that to provide professional zoning services. We say it's legal quality analysis, architecture quality visualization at a fraction of the time and cost. It's just a modern way to do zoning and massing studies. Zoning and massing have been done essentially the same way for 100 years. And so we're trying to change that a little bit. So our reports look something like this at the bottom. There's variations within them, and they could have a little bit more information, less information, depending on what the client wants. But we charge $1,500 for a standard report and promise a 2-day turnaround. That's very competitive both on price and timing. We'll offer a couple different scenarios like a residential building or a commercial building, all depending on what the zoning allows and what the client's interested in. And we also do this on a larger scale. We look at multiple sites or a full block or multiple blocks to kind of create a sort of a more urban analysis. And we will be happy to answer some of the questions now. I'm gonna stop sharing my screen and take a look if we have some questions. So the first question was, is there a way to have a shadow of existing building remain while running different use scenarios? I guess the idea being to see if the existing building exceeds the permitted envelope. So we have the ability to see the zoning envelope laid over the existing building condition. And so I think if I'm understanding the question correctly, the answer is yes, we do that.
Yeah, sorry, I'll just jump in there as well. There's also an option, like when you're running a scenario, you can toggle off the scenario view so you can compare what you're proposing versus what's already there.
Great. So in the geometric shaped Q&A section, there's a bunch of questions, which is great. I'll read them out and I'll address them or address to our team. So are there any academic institutional subscribers? So we are at the moment not a SaaS model, software as a service. We provide zoning consulting services and use the software in-house to power our zoning and massing reports. And so at the moment, external people do not use the software. It's kind of it's a very powerful tool, and in the wrong hands, well, it just leads to a lot of questions. And so we did put it out in beta form a couple years ago, and ended up with people just calling us and requiring us to kind of answer all their questions anyway. And so we kind of pulled it back in-house. Why is knowing who the owner is important to zoning? Great question. The answer is, well, it's not important to zoning in and of itself, but we're talking about sites in the real world that are being traded, being bought and sold. And so to understand who owns it is critical. In an academic setting, the owner may not be all that relevant, but in sort of a real world buying and selling, developing, rezoning, it's quite critical. Ben, looks like your cousin Burke here has a question for you. How did the property name normalizer learn that the non-eggplant properties variation owner was actually eggplant properties? Yeah,
so that was just a small toy example, but if that package dedupe is trained well enough, it should learn like what components of the name and address field are important. And so for that one record that did not have eggplant properties in the name, it did have the same address as a majority of the records. So ideally, the model should be able to learn that, oh, the address might be more important than the actual name. And so we're going to group that non-eggplant property LLC with the other records.
Awesome. Next is, how much ground truthing do you do on a site-specific project versus a rezoning of a neighborhood project? I guess I'm not entirely clear on the details of the question. The rest of the team, Rachel, do you understand the question?
I'm not sure that I do either.
I guess I'll say, I'm not sure if this gets at the question, but accuracy is critical to us. And so regardless of whether it's one site or a neighborhood specific project, understanding the details and the nuances is critical. I say this all the time, so you may have heard me say this before, but we have developed a tool that is incredibly powerful. It is not a toy. It is not meant to just be played around with. No, this could be cool. Something could happen here. This is, people are making real world, big dollar decisions based on the information we provide them. And so we just don't have the luxury to be wrong. So we spend the time to make sure accuracy, and it's accuracy, like we talked about at the beginning of the pipeline with all the data going in, and then on the other end of the pipeline with our team reviewing everything that goes out. Go ahead, Rachel.
We have a clarification in the Q&A further on down there. So field surveys, like going and looking and measuring in the field. Oh, got it.
So we do not go to the field to measure. We rely on our data. What we call the parcel grade or survey grade parcel map of the city, which is our proprietary information, is really powerful and highly accurate. In fact, was put to the test a couple of weeks ago. One of our clients had a site that was a 7-sided or more site. None of the angles were right angles. And so it was really hard to get the exact lot area. We had a little internal bets as to who would be right, whether it would be the city, whether it would be us, whether it would be the client. I lost $2. But I was happy to be wrong because we were the closest. Eventually, we did get a survey from the field, and our number was the closest, better than the cities and better than the client's information. So that piece of it was actually very rewarding to see that we were actually right in that way.
And also, I would jump in there to say that if it was the case that we got a survey and we were wrong, we could enter that number in and the model would adjust to use that updated lot area number as well.
That's right. I was going to say that as well, just to mention that when we do have access to actual survey data, we can incorporate that into our system. So I thought I'd put that out there.
Yeah, that's really useful to sort of always be improving our information as well.
So the next question is, do you plan to scale to other cities with sparser or less consistent data? Yes, we kind of already offer some of our services, some of these zoning services outside of New York. We have sort of created a context-free free of the New York City context version of what we do. It is way less automated because we do not have the zoning rules for every municipality, but we sort of input them manually, but to create the same visualizations for outside of New York. But yes, I mean, we have done pretty deep dives on zoning on many cities, both domestically and internationally, to figure out what is the next right place for us. The complexity of New York City zoning does two things. One is it allows us to shine because the more complex it is, the harder it is for humans to deal with. But the work that this awesome team has done allows us to answer those questions relatively quickly and accurately. And the other piece of it is that I also say this all the time, but the phrase, if you can make it here, you can make it anywhere, very much applies to zoning, that if you can figure it out here, you can figure it out basically anywhere else. Next, is there an option the program can account for a scenario with a potential private open space or public open space in the model as well? For example, a plaza in front of a building. Yes, and then the clarification. Were there questions that came in the chat?
There was one more that what would you need to get going to review another city context? So similar to a previous question.
Right. So we have figured that out. What took us essentially 10 years and millions of dollars to figure out in New York, we think that we could raise a minimum viable product in another city in about 6, 9, 12 months to get something going. It depends on the city, and we would be pulled out there it would depend on the opportunity. New York has a high dollar per square foot value, and so that getting it right in New York is really, really valuable. We had a client who asked us to do work in a different U.S. city, a much less city where development is much less in demand. And I said, well, what does the zoning allow? And they said, well, it doesn't matter. So what do you mean it doesn't matter? They said, well, we're not going to build up to the maximum of what zoning allows. And it's just like when you deal in New York City zoning and development, that's just unheard of, right? I mean, it's the opposite, right? You're trying to always exceed what's permitted. Here, I asked what was permitted, and they said it doesn't matter. And that was hard to wrap my head around. But that's our 46 minutes. I'm happy to take another question if there is something specific. Anyone, please put it in the Q&A. If not, I'll say on behalf of all of our team, thanks again so much. What a treat it is to be part of Open Data Week. This was fun. And please, if you have questions for us after this, you can just email info@envelope.city. You can look us up at www.envelope.city. Email us, and we'll be happy to chat. All right. Thanks, everybody.
Thanks, Eldad. Thanks, everybody.
Thanks, everyone.